Welcome, prospective general contractors. Okay, if you're gearing up for the Florida Certified General Contractor exam, you probably already know that the building codes can feel like this dense, totally impenetrable fortress of numbers and rules. It's overwhelming, right? But here is the secret to actually mastering this material. You can't just read the code, you really have to visualize it. So, in today's explainer, our goal is to transform those incredibly dense code manuals into a memorable, structural mental framework. By the time we wrap up, you aren't just going to be memorizing drive facts. We're going to build a mental house together, piece by piece, perfectly aligned with Florida's extremely stringent energy standards. Let's get into it. Okay, let's dive into this. Our foundation for today is the Florida Certified General Contractor Technical Master Guide. More specifically, we're going to be dissecting the state-specific reference for energy-efficient building construction in Florida, which ties directly into the Florida Building Code for energy conservation. Think of this as your ultimate playbook. It dictates all the mechanical, thermal, and structural rules you absolutely have to follow. And trust me, the examiners absolutely love testing you on this specific section. But to really ace these questions, you first need to understand the logic behind the code. Like, why is building a house down in Florida so radically different from building one in, say, Ohio or Colorado? Well, it essentially comes down to one core concept. When you construct a building in Florida, you are basically building a giant cooler. Your primary enemy isn't the freezing cold, it's extreme heat transfer and just relentless moisture from the hot, humid climate. Literally every single rule we cover today is designed to protect the integrity of that cooler. To build our mental cooler, we're going to construct this house from the outside in, following the exact path that heat and moisture take when they try to invade the building envelope. We'll start with Florida Climate Code basics, then hit the thermal envelope and R values, followed by vapor retarders and moisture. After that, we'll cover sealing air and ducts, move on to windows and heating limits, and finally finish up with sizing Florida HVAC systems. First up, Section 1, Florida Climate Code Basics. Now, geographically, Florida is split into climate zones 1 and 2. Whenever you see a question referencing these specific zones, you need to instantly shift your mindset to one thing: defending against intense heat and high humidity. Moving on to Section 2, the thermal envelope and R values. This is where we actually start building the exterior shell of our cooler. And remember, the higher the R value, the greater the resistance to that heat flow. I want you to take a mental screenshot of these numbers right now because they are highly, highly testable. For standard wood-framed residential construction, your ceiling and attic insulation needs a baseline performance of R30 to R38. Now, when it comes to mass walls, think concrete block or CMU. You basically have two choices. You can either deploy continuous interior furring with R5 insulation or use exterior continuous insulation tracking at R6. Oh, and here is a very specific favorite exam question. High-density R30 bats used in cathedral ceilings. How thick do they need to be? They must be exactly 8.25 to 8.5 inches thick. I'm serious. Lock that 8.25 to 8.5 inch figure firmly into your memory. Now, what's really interesting about this slide is how the code actually handles real-world physical limitations. Because sometimes the pitch of a roof means you literally just don't have the physical space of the eaves to hit your standard R value targets. So the code allows an exception. You can reduce your attic insulation to R30 if space is insufficient, but there is a very strict cap. You can only do this for up to 500 square feet or 20% of the total attic area, whichever is less. And regardless of what you do there, a continuous air barrier has to be provided throughout the entire building thermal envelope. No exceptions. And here's a rapid-fire compounding rule that you absolutely need to know for the math portion of the code. If you are installing two distinct layers of bulk or board insulation, how do you figure out the final thermal resistance? It's actually just simple addition. The R values of each individual material can simply be added together to get your total R value. Pretty straightforward, right? All right, Section 3, vapor retarders and moisture. Now that we've armored our cooler against the heat, we have to shift our focus to Florida's other main invader, which is that relentless, sticky humidity. So in a warm, humid climate, moisture is always going to travel from the hot exterior toward the air-conditioned, cooler interior. It's just physics. Because of this, vapor retarders must always be placed on the warm and winter side of the thermal envelope. In Florida, that explicitly means the exterior, or the outward-facing side of your framing assembly. Listen, if you accidentally place a low-permeability vapor barrier on the interior wall surface, like right behind the drywall, The warm, humid air is going to push through the exterior, hit that interior barrier, condense into water, and just stay trapped inside the wall cavity. You're looking at catastrophic structural rot and toxic mold. So remember, place the barrier on the outside. Now moving down to the foundation, the code has very specific rules for unvented crawl spaces to stop moisture from wicking up from the soil. Once you're actually in the crawl space, look down at the vapor retarder on the ground. The state code mandates that the vapor retarder joints in an unvented crawl space have to overlap by a minimum of 6 inches. And not only that, they must be physically sealed or taped. Quickly anchor that 6-inch overlap rule into your spatial memory of the home's foundation. It comes up a lot. Okay, Section 4, sealing air and ducts. We're moving inside the envelope now to actually test the integrity of the seal we just built. Believe it or not, air leakage is an area a lot of builders completely overlook. To prove your cooler is actually sealed, the state requires a blower door test. Here is the exact procedural flow. First, the building envelope is pressurized to 50 pascals. At that specific pressure, the code dictates that the target air leakage threshold must fall somewhere below 3 to 5 air changes per hour, or ACH. The absolute maximum air leakage rate allowed in climate zones 1 and 2 cannot exceed 7 air changes per hour. If it's higher than 7, well, your cooler has holes in it, and you're going to fail the inspection. I want you to forcefully stamp this next number into your brain. Less than 4 CFM. The code clearly dictates that all supply and return ducts located outside the conditioned envelope, so think of ducts running through a blazing hot attic, they must be sealed using mastic and then thoroughly tested. Your total duct leakage testing has to track at or below 4 cubic feet per minute per 100 square feet of conditioned floor area. Section 5, windows and heating limits. Because now we're looking at the intentional gaps we have to put in our cooler. The sun beating directly against a glass window is easily one of the fastest ways to introduce unwanted heat into our perfectly sealed environment. To combat this, the Energy Star criteria for the Southern Climate Zone requires a maximum solar heat gain coefficient, or SHGC, of exactly 0.25 or less. To put that into perspective for you, a standard double-glazed window with quarter-inch tinted glass only has an SHGC of about 0.4 to 0.7, so hitting that 0.25 requirement means you are installing high-performance, severely heat-restrictive glass. And what about heating? Well, as we know, Florida's built for cooling, not heating, so the code actually states that the absolute maximum heating design criteria allowed in the state is 72 degrees Fahrenheit. That's a hard cap. Finally, Section 6, sizing Florida HVAC systems. We've officially arrived at the mechanical heart of the home, and the equipment here has to perfectly match the sealed envelope we just built. Listen, gone are the days of contractors just throwing in the biggest AC unit they can find on the supply yard. Florida code requires that all HVAC equipment be sized strictly in accordance with ACCA Manual J for load calculations and Manual S for equipment selection. Why is this enforced so heavily? It's all about the real-world consequences of oversizing. If you put a massive air conditioner in a perfectly sealed house, the unit cools the air down so incredibly fast that it immediately shuts itself off. This is what we call short cycling. And the problem is, an AC unit doesn't just lower the temperature, it also acts as a dehumidifier. So, if it shuts off too quickly, it fails to remove the moisture from the air. And what happens? It leaves the house feeling like a cold, sweaty, humid box. So what does this all mean? Well, it brilliantly illustrates why studying for the GC exam is about so much more than just passing a test. By memorizing those 8.25-inch cathedral bats, understanding the strict exterior vapor retarder placement, and nailing those 3 to 5 ACH blower door limits, you aren't just getting your license, you are guaranteeing comfort and safety in literally one of the country's harshest climates. So, as you prepare to step onto your next job site, ask yourself, will the homes you build stand resilient against the Florida elements, or will they become sweaty structural liabilities? The choice and the knowledge to make it starts right here with these codes.